Good morning, everyone. Thank you for joining our session today. I hope everyone is safe. Welcome for joining us back. Today, we are back with our session number 6, which is around AWS database service and analytics service. To cover this wide range of services with us, we have Yash Badani. Let me give you a quick introduction about Yash. Yash works as a senior big data engineer at Quantify Analytics. It's his day in day out job to work on different AWS database and analytic services, includes Redshift, Aurora, Glue, and all. So we'll have Yash today covering the different sessions, the different services, how he interacts with the services, what are the best thing about it. That's exactly we will be covering around this service. So I will like to invite Yash.
Hey, hi, everyone. This is Yash. Thank you, Sanchit, for the good introduction. And let's get started. I think we are almost time. Let me share my screen and we can start. Let me know if you're able to see my screen.
Yes, you're all set. Go ahead. Thank you.
Okay, awesome. Thanks, Sanchit. Okay, all right. So, welcome everyone to this amazing session on the database and analytics services. Today, in the Solution Architect Associate Certification Bootcamp. So, the database and analytics services, right? So, we'll be covering the following 7 services that we have here. Starting with RDS, ElasticCache, DynamoDB, and Redshift, which help us to store the database and also continuing with Athena, Glue, and Elasticsearch, which help you to get insights and also query your data and do ETL as well. So let's get started with RDS. So RDS is like your relational database, which is hosted on cloud on AWS. It is easier to set up, operate, and scale a relational database on AWS using RDS. Of course, you get all the benefits of an AWS cloud here to use RDS, which provides you pay per use. You can resize the capacity as required. And of course, this is a very compliant database, industry standard relational database. And it also manages day-to-day administration tasks for you, which are very much critical for a DBA. So it reduces the overhead over the DBA and makes it sort of a no ops approach on that side. You can just focus on your application and on your users and let Amazon AWS handle all of your heavy lifting on the operational side. uh, if you have gone through the EC2 videos, right? You must have noticed, you will have a question that why can't I host a database on EC2? And the reason that you can, but why you shouldn't is because these are the features that RDS supports automatically. And once you opt for an RDS, you also get to know and also get to use auto scaling, a high availability option. You also get automatic software patching, OS patching, and getting to back up the database automatically as well. Whereas in EC2, you will get more of a DevOps approach on this side. So this is the table where you see the differences of why you should use RDS as against in EC2 for hosting your databases. Note that this is a managed database service, so you cannot SSH into this particular instance. This is not like your EC2 instance where you can SSH. So of course, you will get a question of, okay, how do I manage my database? How do I configure some of my parameters of the database? So AWS helps you to do that within the console itself using something called as parameter groups, and we'll see that later. So as I mentioned, RDS doesn't require any special handling. You In your application, you can just point to it, right? Just like your normal endpoint. As against from your on-premise systems, you can just point it to RDS, the endpoint that it provides you. Of course, if your RDS is in a private subnet, then you will also have to use a bastion host or a proxy server in between so that your applications can access. Or if your Amazon account is linked with the network, with your corporate network, you can directly use it, just like a normal database. You have something called as an instance class in RDS, where you select how much RAM, how much processing power you require, and of course how much storage is something that you can select in RDS. Amazon RDS currently supports these six instance database engines. It's actually five: MySQL, MariaDB, PostgreSQL, Oracle, and SQL Server. And there is a different offering which is called as Amazon Aurora. And we'll talk about Amazon Aurora in some time. As I mentioned, each database engine has a set of parameters which you can configure using a DB parameter group to control the behavior of your databases, right? Uh, let's say you want to set up a time zone of Eastern. Let's say you want to set up a Eastern time zone to your database, so that by default, whenever database creates a timestamp, it's of an Eastern time zone. You can do that by setting up a parameter, time zone parameter, in your server. But here, this is like a no ops approach, where you are not getting to access your server and the configuration files. So in this case, you have something called as a parameter group that is attached to your RDS instance, and you can use these parameter groups to configure, let's say, a time zone, or let's say a buffer pool size increase, or you can do actually anything that you normally do within your config files of the databases. You need not worry about all of this. We can move on to the next topic, which is how RDS maintains a backup and a snapshot. Okay, so you can configure your relational database or RDS instance to have a backup, and the retention period can span from 0 days to 35 days, where 7 days is by default. So whenever you spin up a new instance, it's actually 7 days by default, and you can increase it up to 35 days. Note that these backups backup the database within your backup the data within your database instance, right? It doesn't back up your whole instance in itself. So what backups do is it leverages transaction logs within your database, and it backs up every 5 minutes. So every 5 minutes you will see a transaction log being written to a backup, right? So actually you can get a recovery point objective of around 5 minutes in RDS, within 35 days of period. So you can actually restore to any point in time. That's what we can say, right? Talking about snapshots. So people often confuse between backups and snapshots, but snapshots are actually different, and they actually are a copy of your instance itself, right? And they do not expire like we have backups here. You can have as many snapshots as you want. There is, of course, a limit to the number of snapshots you can have within your Amazon account, and that limit is a variable limit. Snapshots do not expire, as I mentioned, and they have no retention period as well. You can schedule your RDS instance to snapshot automatically every day, every few hours, and we call them as automated snapshots. Okay, and these snapshots are actually stored in S3, as you can see here in the picture representation. And how snapshots work, right? The concept of snapshot, regardless of any AWS service or any services outside, uh, snapshots work basically where your first snapshot is like the whole image of the instance, right? Whole image of anything that you're taking a snapshot of. The subsequent snapshots are incremental. So let's say you have data like you did a snapshot today, and you had data starting from 2021. You will have the data of the whole 2021 year, as well as the few days in 2022 within your first snapshot. And now, if you schedule a snapshot to be done daily, your subsequent snapshots will now store your data like just of one day. So you'll get data of, let's say, today, for the snapshot that's created today. For the snapshot that's created tomorrow, you'll get a data of tomorrow. But whenever you use a snapshot, right, this is like an abstraction, an optimization to store the data. But whenever you try to access the snapshot, you will of course get the whole data. That's how snapshot works. You can copy and share your snapshots to different regions in AWS, so that you can, let's say, launch your instance, a copy of a database into another region, and so on and so forth. There are other advantages to this that we'll look forward later in the slides. Moving to the scalability and the availability factor. So this is the most important factor that we are going to discuss here. Also, when it comes to architecting solutions on AWS, this is very important to know. RDS scales up your storage size automatically. If let's say it falls below 10% of your storage size, and this is true for at least 5 minutes. So let's say you have a variable workload, and that workload tries to stage a lot of data and then aggregate the data. So let's say your staging data is a lot, and it's taking like less than 5 minutes for your storage. I mean, the storage is full at this point, almost full. Your RDS won't scale it. But if let's say it is greater than 5 minutes, your RDS will tend to add a few gigabytes to it every times until it scales. So this is an option that you can select. It's not compulsory. It's not mandated that you will automatically have the storage increasing. You can configure it to increase, like scale up this way. And this can be also controlled. So let's say I don't want to go above 1000 gigs, let's say 1 TB. I can do that by setting a maximum storage capacity flag, and say I add, okay, I don't want anywhere above 1000 GB. Then it won't scale above 1000 GB. And let's say if your RDS tends to go to that particular figure, then it will show you an error of a storage full. Now, coming to the most interesting part of RDS, which is read replicas, right? So, read replicas, as the name mentioned, you will have a read-only instance, which is a replica of your master instance. So, let's say you spin up a RDS instance, and now you created, let's say, a replica of it within the same availability zone. You can do it across the availability zones within the same region, or you can do cross-region replication as well. Okay, this replication is asynchronous. So you may happen to see, okay, your data is not replicated instantaneously to the read replica. Let's say you try to read within a second. It may happen that, okay, your data is yet still not replicated. So basically, how these replicas work is it leverages transaction logs within a database, and it tries to replicate the same to the other instances to which it is linked. So you have like a primary database within, let's say, in US East 1A, and you can have another database in US East 1A, or you can have another database in US East 1B, and you can have like asynchronous application between these two. Note that this is a read replica that we are talking about. So you cannot write the data into a read replica. You will always have to write your data into your primary instance. As I mentioned, like this is like a standalone database in itself, which is a read-only database. Now, let's say something happens to your database, and you want to fail over to a different database with having a minimum recovery time objective, or let's say I want to have a minimum downtime, right? So let's say there is a disaster. Something happened with the AWS region or availability zone, and I want to switch to a different instance that I already have. uh, let's say I have a read replica in a different region or in a different availability zone. That's easy to do. You can just upgrade that read replica into a full-fledged primary database. Yes, you can only have up to 5 replicas per instance, and there is no additional charges to replicate your data. The only charge that you pay is for the storage and the additional capacity that you will provision for your read replica. And of course, the very obvious advantage of having a read replica is it reduces the read latency, right? Let's say there are a lot of reads into a database, and there are some mission critical applications which require the response within a few seconds. You can do that by pointing them to read replicas. Note that read replicas can also auto scale in some special cases that we'll talk about later. And cost region replication is chargeable because you have a data transfer cost from one region to another region. And as I mentioned, multi-AZ replication is free in read replicas here within the same region. So that's an amazing point. So as I mentioned, there are no additional charges for read replicas within the same region. You only pay for the additional capacity and storage that the read replica will consume. Talking about a multi-AZ deployment, right? Um, Note that read replica is used for scaling out your database, right? You want to scale out your reads into multiple clusters, so that's when read replicas come into picture. But what if I want high availability? What if I don't want, let's say, I don't want a downtime as such when I try to sort of upgrade my read replica into a master, a primary instance, like we saw in the point number 2 here, right? What if I want to do uh, faster than that? I'll use multi-AZ. Multi-AZ is mainly used for high availability. So multi-availability zones, as the name says, you can have a database synchronously replicated between the two availability zones. Note that this is only for the same region, right? Why do you require such multi-AZ deployments? Is you want this to you want your database to be fault tolerant, and you also want your disaster recovery to be faster, right? Also, in the multi-AZ option, you do not have an additional cost for application, and it is free within the same region. Likewise, we had in the read replicas as well. So it is free of cost. You only pay for the additional capacity in the storage of your standby instance that we call in RDS, right? And all you need to do is, let's say, when your application is trying to access a master instance in the US East 1A, and US East 1A has now some issues, then in that case, you can just modify your DNS record so that your application now directly points to a standby instance, which is in US East 1B. This is how read replicas and multi-AZ work. This is a very interesting topic, and there are some more improvements in the upcoming slides that you will see, and we'll talk about later. Now let's go to the demo of how do you provision, and we'll see how AWS console is for RDS. So as you can see here, we already have a provision database here. And let's say I'll just walk you through the create database of how we can do it. So let's say you create this create database, you get this option to select standard create or an easy create. Let's say we go forward with a standard create, just to know that what are the different options that you can use. Amazon Aurora is a different offering that we'll talk about in some time. Let's move to, let's say, another engine option. Let's say MySQL. Okay, you can select the version of the MySQL here. Let's say I want to work for my MySQL version 5.7. I can select that. If I want to use MySQL 8, I can use that as well. You have MySQL 5.6, 5.7, and 8. Of course, these are major improvements in MySQL, so make sure you select the one that is already being used, or make sure you use the one that satisfy your business requirements. So you have an option to select a template here, right? So for a production ready template, you will get some more options here, because your production ready workloads need to have that fault tolerance, that scalability that we just talked about, right? You can also create a template. There is also a template for dev, so which will give you some lesser options to select from, right? Let's say we go forward and selected production, right? As you can see here, right, automatically when I select dev, it moves to a single DB instance. But when I go to production, it moves to a multi-AZ DB instance. Why? Because I want fault tolerance and I want standby DB instance in case things go wrong, right? In my production, I don't want to basically take any risks of having a downtime, right? So let's say I go forward with a production ready workload here, and I select a multi-AZ DB instance. As this one says, it creates a primary DB instance and a standby DB instance in a different AZ. Mainly provides you a high availability and redundancy of the data. uh, you can give an instance identifier. This is like a name of your database instance. You can also set a username and a password. You can also auto generate a password. That's not a problem. You can now select instance classes here, right? So for production ready workloads, it is recommended to use M series and R series. For your development workloads that you select here, it is recommended that you use a T series class. You can of course use the other classes as well in your development. Let's say you have a lot of data that you are trying to build something out of. You can of course have to use, you will of course have to use R series and M series. Let's say I go forward and select the T series, and you will see that I get the options of T3, right? Let's say I want to go with a free tier approach where T2 micro is having some free usage for a few months or a year. So when I select T2 micro, right, I can have that option only when I enable this. uh, you can have your storage provision or general purpose, right? Or you can have a magnetic one, which is not recommended, which is legacy. And based on what you use, if you use provision, then you will have to provision your IOPS. And if you select SSD, you just need to allocate the amount of storage that you require. So as you can notice here and here as well, by default, it is giving you 1000 for provision IOPS SSD, and for general purpose, it will only give you 20. You can enable scaling for storage. As we talked about in the previous slide, we have auto scaling for storage. And you can also define a threshold. Well, let's say I want to keep around 1000 GB, which is my maximum threshold, so it will automatically increase from 20 GB to 1000 GB. And this will automatically increase based on your workloads. Also note that this is a GIB, which is not a gigabyte. It's like a gigabyte. A difference between a gigabyte and a gigabyte is a gigabyte is 10 to the power 12, but a gigabyte is 2 to the power 40. So you approximately get more data in a gigabyte. It's more around how you allocate the memory and how the memory is distributed. So on cloud, usually you will come across such nomenclatures called as gigabytes and not gigabytes, right? So GIB is that nomenclature, and it's 2 to the power. So GBs are of course 2 to the power 30, right? Terabyte is a 2 to the power 40. Moving forward, you can select a VPC within which you want to deploy your instance. You can have like a secure deployment by having your database within a private subnet, right? And there is a concept called as a subnet group. Now let me take a step back and explain you what a subnet group is. We talked about parameter groups where it has a group of parameters which you can configure, right? Why subnet groups will be required? Let's say you deploy a database in a multi-AZ configuration, right? A subnet spans an availability zone within a region, right? And your VPC is within a region. What happens is when you try to do a multi-AZ deployment, you can deploy your database within that same VPC and within that same subnet group. So let's say I have like 6 different subnet groups within my VPC, and I only have a subnet group of 3 out of them created in RDS. I can deploy my instance within this another subnet, another group of subnet, which is a 3 subnet group, and I can have my multi-AZ deployment within that group to make sure that whenever I do a multi-AZ deployment, I have an availability zone which can be selected from this group only, right? You cannot span across subnet groups for a multi-AZ deployment. It should be within your same VPC. Of course, if you have like cross-region replication, that's a different story. But at least for multi-AZ, that's how it's done. You can have an option to either have no public access or have a public access. So this is true only when you deploy your database in a public subnet. So when you click on yes, your database is publicly available. If you click on no, your database is not publicly available, even though it is in a public subnet. Of course, you have an additional line of security, which is called as security groups, right? Even though you have publicly accessible database, your security groups will make sure what incoming traffic should go in and go out, right? Uh, and You can select or create a new security group. Note, you will have to open a port on the Aurora, MySQL database in this case that we selected above. So MySQL is 3306. So let's say I want to open a port on 3306 within this particular security group. So I can do that. Okay. Uh, as I mentioned, this is a database port which you need to open. Database authentication. So we'll talk about the security aspects in the next slides. But this is what I just wanted to walk you through around what is the uh, what is basically all of these parameters that you can configure while setting up a RDS instance. And basically, when you come to additional configuration, you have like initial database name that you want to give. You can select a parameter group. You can create an option group as well. So all of these are different parameters that you can set up for a database. That's what I think you can remember for now. And you can enable automated backups. So as I mentioned, by default is 7 days, and you can go up to 35 days. uh, this backup can happen within a select window, and if you don't have a preference, you can select no preference. Note, there is no downtime as such when the backups are created, because these work on transaction logs, right? So that's asynchronous, and that happens every 5 minutes. Also, you can enable enhanced monitoring, which will give you some more insights around the monitoring aspect of your instance, which will make sure that you know when your database scales out, when your database needs some more capacity, and things like that. Uh, uh, you can have like a granularity of 60 seconds. So every 60 seconds, event will be returned, and like it will help you to monitor every 60 seconds. There would be a metric that will be pushed. Monitoring role, you can select if there is a monitoring role that you have created, or you can create this and select the default monitoring role. So of course, this is used to allow your database to be monitored using the enhanced monitoring feature. Now you can of course have an option to export your logs, right, to CloudWatch. So databases generate audit logs, error logs, general logs, and slow query logs. All the database have that feature. So audit logs is something that gives you an idea around the accesses and other table related stuff. Error logs is of course the errors that the name mentioned. General logs are all the logs that you do. So every query you do, that's a general log. A slow query log is basically when a query takes a lot of time. I think there's a threshold that you can define, and if it crosses the threshold, it's categorized as a slow query log, and it's pushed to a slow query log file, and you can have that published to CloudWatch. And of course, you can do things with CloudWatch, right? So that is very much helpful to do. You can select a IAM role for this one as well. You can enable your RDS to automatically upgrade minor versions, right? And you can do that within a maintenance window, just like for the backups. We have a backup window for maintenance and automatic version upgrades. You can have a window or no window, right? You can enable deletion protection, and here after selecting all of this, you'll get option to have like estimate of your monthly cost. So this deployment will be $30 USD for me, right? I've already created a database instance, which is like a dev test database with a very minimal configuration for you all. So this is the database that we have, right? And as you see here within the database, once the database is created, you will have like an endpoint to connect to, right? But you cannot connect to this database until you do a security group configuration. Now, what is this? If you go to the security group configuration here, so within your inbound rules, if you see here, you'll have to allow your MySQL Aurora 3306 to your own IP address, right? Right now, I have not enabled to be open to my computer's IP address, and the real reason is I will not access this database within my from my laptop, right? So what I've done is I've already created like instance from which I will do an SSH. Okay, so let me go and SSH from the instance to this particular database with all the credentials that I've already added to this database while creating it. Okay, so this is the database that we have here, and yeah, so I have like a sample for you. Uh, let's say I've already created like a table and things here. You see here, this is like a very small and simple table that's already created. So this is how you can access the database. And as you can see here, right, from the string that we have here, the string, as you can see, doesn't do anything much. So it is very much easier to migrate from an existing application that depends on an on-prem MySQL database to move into a MySQL that's hosted on AWS. It's that simple. Okay. Moving back to the RDS console, as you can see, the public availability is also yes, right? And now moving to like all the other tabs here, you will have monitoring enabled here. So you will see, okay, there is one connection from me that just got logged here, as you can see, and the CPU utilization is around 5% at max, right? And when you check here the logs and events, you will get like a database instance was created, right? And it was restarted here, right? And there was a backup that happened at 10:35 uh, uh, am UTC, right? So all of this can be found here. You will have error logs. So all of these error logs can be found here. You can download these logs and see what the error came in, right? As I mentioned, this is like a totally no ops approach for the database administration and operations, and you get the AWS console to help you do all of that. So the only way you can download a log is from here, which is an error log, right? You also have the other kind of logs, which is like running log and things like that, and also like a MySQL upgrade log. Go into configurations. As you can see, this is a MySQL 8.0, and we have like one CPU, 1 GB RAM. It's a very basic configuration of the database are created. You have 20 GB of storage here, and the max and storage auto scaling is enabled up to 1000 GB bytes. Okay. There is no multi is enabled, and deletion protection is disabled. You can see all of this here in the configuration. You can go to the maintenance and the backups here and also see what is the maintenance window, what is the backup window. I did not select a preferential window, so I've selected no preference due to that. This is like a random window that was selected. Okay, and these are the snapshots that the RDS creates for me automatically, right? So you can provision, you can create a snapshot, which these snapshots are called as an like manual snapshot. You can also enable automatic snapshots, where your database is supposed to take snapshots after certain time, right? So you can see here there are automated snapshots created here, right? And similarly, you can define some tags for some cost tracking and other tracking purposes and tagging purposes. So when you go to this database and select on actions, right, you will get an option to create a read replica. So we just saw, right, and we talked about read replicas and all. You can take a snapshot. You can restore to a point in time. Let's say you want to recover some of the data to a point in time within your backup retention period. You can do that from here. You can also migrate a snapshot from one region to another region. Let's say you create a read replica, right? We'll create a read replica here. So as I mentioned, read replica is like a standalone instance in itself, but that instance cannot be written. I mean, you cannot write the data within that instance. That instance is only for reading, right? So, but still that instance is a standalone instance. So you can do that here, and you can select all of the things. You can have a different configuration, of course, because it's a new instance in itself. Only your storage is being written. Your compute can be different, right? You can select all of these things here, and also select where you want to keep this particular replica, right? So let's say I want to keep this replica in a different availability zone, right? I can, and as I mentioned, you will have to select a subnet group, and it should be the same subnet group. Or let's say you, if you want to do it in a different subnet group, you can surely do that. Probably not recommended, because we'll just talk about that in the next slides. Why not to do it, and why it is important, or maybe why it is beneficial for you to not to do it. Availability zones, you can select which availability zone you want to keep this as. So right now I have it in North Virginia, which is the US East one. So my existing database is already in US East one, I think A or B. I will create it in US, let's say in a different region if I want to create, or in a different availability zone within the same region, North Virginia. Let's say I want to create it in a different region. I want to create a cross region replica. I want to enable cross region replication. Okay. I'll select US East, which is in Ohio, and not North Virginia, and we'll see what it does, right? So when I create a read replica here, right, it will now go and create that read replica for this particular database for which I want to create, right? Okay, I didn't provide an identifier, so let's say I want to give the identifier as database one RR. Okay, read replica. I create a read replica here. Hopefully, it doesn't give any more errors. Anything that we missed setting up? Yeah. So your read replica creation has been initiated. Okay, so you will not be able to see it here, right? You cannot list it here. Probably, if you just scroll down here in the security and connectivity and security, right, you will see that, okay, you have a DB instance, which is a replica here, which is in US East 2, right? That's still being provisioned. So if you move to this particular region, right, you will see that a replica is being created. Yeah. So as you can see here, it's being created. It's an Ohio region, right? And it's like a replica, and it points to this primary North Virginia, right? And this will take some time, but just to tell you, with I mean, you can also demonstrate it yourself, where you try to connect to this particular instance. So here, instead of this particular endpoint that we just logged into, right? You can just log into database one RR, and whatever the endpoint is, right? So let's say it's a different endpoint. Whatever the endpoint is created after this is provisioned, and if you say, if you just sort of connect to it, right, and you try to insert a data into this particular table, it will not work, because it's a read replica only. It will throw an error that this is a read only database. So I hope this was helpful for a walkthrough around the RDS. And let's move on to the next slide here, which talks about the security and encryption. You have like at rest encryption of AES 256 using KMS. You have SSL encryption, in-flight encryption, and for encrypted databases which are encrypted while during the time of creation, automatically your backups and your snapshots, your read replicas are also encrypted. So that's a good feature. And the same is true vice versa. So if you're trying to restore a database from a snapshot or from a backup which is encrypted, it will automatically create an instance which is already encrypted by the same key. So that is really good. But what if my database is not encrypted and I want to encrypt this database? What you can do in this case is, so snapshots, when you create a manual snapshot, that particular functionality is only responsible to create snapshots of the data, right? It is not responsible to now encrypt your data. So for an unencrypted RDS instance, you need to create a manual snapshot first. There is an option to copy the snapshot, right? And while copying the snapshot, there's an option to encrypt this new snapshot that is being created. So the snapshot number two will be encrypted now. And now you can restore this snapshot number two into a new RDS instance and decommission the old instance and sort of update your DNS records. Of course, this comes with a short downtime, and you will need to basically think about the maintenance windows that you provisioned for your previous, the decommissioned old instance, and do the same during this one, uh, d- during the same maintenance window, right? As I mentioned, RDS instances are generally deployed within the private subnet group, and a further access is granted by a security group. So this is still, this is another security option that we have within RDS. And the best part is MySQL and PostgreSQL supports IAM authentication, where users are not managed in DB. So you can add users in DB and use that general username and password that we have. But rather than using it, you can use IAM authentication, which will leverage the IAM permissions and the user list within your IAM to make sure that that particular user is allowed an access or not to allow an access. SSL is required by default for IAM authentication, and if you are strongly within the AWS environment and your network is totally linked, your corporate network is also linked uh, with the AWS, it is strongly suggested that you link your AD and you use SSL and of course enable IAM authentication, so you can directly log into your database without requiring any sort of a username and password as such, and you can just directly use SSL certificate, and the token that IAM will automatically communicate to your application through which you are connected to the database, right? There is another option for SQL Server and Oracle database engines, which is called as transparent data encryption. That this is a different kind of encryption for some compliancy and other data that is quite important, and you can enable this as well in SQL Server and Oracle through the parameter groups as well. uh, Moving to Aurora, right? The other, another offering that we were talking about. So this is an Amazon offering for an high performance and scalable RDBMS. It's 5 times faster than MySQL and 3 times faster than your PostgreSQL, right? And I mean, when we compare this, we are already comparing with RDS and not like your on-prem systems. So it's that fast. Um, so what's the difference? So an Amazon Aurora database, it's like a fully managed relational database with MySQL and PostgreSQL, of course, we just talked about, and it includes an high performance distributed storage, right, across availability zones. So the storage layer is distributed across availability zones in Aurora, and you will have replication of the data as well. Like you will have around 6 copies of data across 3 availability zones for backup and recovery. So what this will help with is it will give you resiliency. It will give you a quick recovery from the data loss, and also you can have lower latencies while doing this backup, because you can have, let's say, a failover into a different availability zone, and you already have the database in that availability zone. You already have the data in that availability zone, a copy of that data, right? So that's what the second point talks about here. And the storage and compute are isolated in Amazon Aurora. As I mentioned above, the storage the storage layer is totally redefined for Aurora, and it can grow automatically as needed up to 128 terabytes. Terabytes is 2 raised to power 40, and when you compare a terabyte with a terabyte, it's around 10% increase than a terabyte. uh, uh, I mean, what Aurora does is, so Aurora databases have a cluster, right, in itself. So, and there is a master node and there is a read replica. You can have up to 15 read replicas as against the 5 or 6 read replicas that RDS was supporting. So Amazon Aurora gives you 15 read replicas, an option to also auto scale that read replica, right? And auto scaling will happen within your availability zones, right? So you can have a master node where your write request will go. Your write request will always go to a master node, and that will be replicated to other read replicas. Let's say you have 15 read replicas you created across the availability zones within the region. You can do that, right? And you can also have like cross region replication for DR activities, and you can have automatic failovers also to that particular DR. Of course, it takes some time to fail over to that uh, other read replica to upgrade to a standalone primary database, basically another master node within my cluster. So let's say you have a cluster with one master node, 5 read replicas, and your master node fails. Any one of your read replicas can now upgrade to a master node, and now you have 4 read replicas and one master node, right, instead of 5 read replicas. So automatically Aurora will add another read replica for you once there is a recovery within the availability zone within which the disaster happened, right, or the downtime happened. So it's self-healing, we can say. There are Aurora endpoints. We have writer endpoint, where to which you point your master node to. You have a reader endpoint, which is common for all the read replicas. So here comes the interesting part. So let's say you have like 5 read replicas. You should not use the separate endpoints for those 5 read replicas. The reason being, let's say you have downstream applications which are trying to read data quite often, right? And there is no writing as such from those downstream applications, but you want like a minimal latency. You expect minimal latency from them. So what Aurora does is it intelligently routes your requests across the read replicas, and it can also auto scale your read replicas to make sure you get your data within the stipulated time or the SLA that you might have defined with your client. So that's what the reader endpoint does, is it automatically scales your reads into multiple read replicas, and it can also help you auto scale your read replicas, right, based on requests. You can have custom endpoints. So let's say you have a read replica which you want only for BI dashboarding, right? In that case, you can just create a custom endpoint, and that will help you offload like specific heavy analytical tasks, or maybe visualizations. Let's say the dashboard is being often queried by the end users. You do not want your database to overwhelm. You can just create a custom endpoint and point that BI dashboard to this particular new custom endpoint, so that your reader and writers are still available for your mission critical applications, right? Moving to another offering. This is quite interesting, and due to the reason that it has a lot of things, I've already added like a link here down below, and you can sort of also Google and maybe just reference the slides later on, and go to this link and just read about it. It's very interesting to know as a database engineer. I would strongly recommend to read it. Some of the very important points here, right? As the name suggests, this is a multi-master configuration, as against your normal cluster which had like one master and multiple read replicas. This one will have all the nodes as master nodes, right? uh, the concept of failover doesn't apply here. The reason being, you already have like a master instance available, so you need not upgrade a read replica to a master instance. So instead of calling it as high availability, we call a continuous availability. Your applications will automatically switch from one master instance to another master instance. So you need to make your applications that way. You need to develop it that way that it is fault tolerant and can switch to a different master instance, right? So it's continuous availability and not high availability in this case, which is really good. But there are some caveats. The caveat number one is there is no cross-region replication here. And you only have multi-AZ support. There is no auto scaling of the queries across read replicas because there is no concept of read replicas here, right? Because all the instances are master instances. Uh, so this is similar to like a single master clusters, and the difference lies in how many master instances you have, right? And let's say you have 4 instances, then you will have replication within those 4 instances, and that's the maximum number of nodes that you can have within your cluster. Your application controls which write requests go to which master instance, so that's good, as against in a clustered environment in the previous Aurora where you had one master, multiple readers, and you need to, whenever you need to write the data, you always need to point to the master instance, your primary instance. Here in this case, you can just point it to a different master instance, right? So this will help you to basically offload some of your tasks into a single master instance and some of the other tasks into different master instance. So when I talk about this particular use case, multi-tenant applications come into the picture, where you share the same infrastructure across different users, and you want to sort of improve the availability of the data, and you also want to improve the rights, right? In that case, multi-master is a configuration. Basically, it is a way to go. Also for the databases which require strong consistency, less latency in writes, right? And there is a lot of other points that you can just check out in the link, but these are some of the very important points, and you can just go through these later. And I mean, as I mentioned, like with multi-master, you just connect to an individual instance, right? So it's not like there is like one endpoint through which you will connect. You will have one endpoint each for every master. So you develop your applications likewise. Moving to the next part of the story, Amazon Aurora serverless. In the previous cases, I think one of the major caveats what I see personally is, what if I do not provision the capacity correctly? Okay, what if I gave a lot of memory, a lot of CPU uh, to my instance, to my cluster. uh, I'm actually paying the price for it, right? Per hour or per day or per minute, right? I don't want to pay that, and I do not have predictable workloads. My workloads are uncertain in nature, and in that case, I mean, it's not possible to have provision model, right? I need some sort of scalability, right? And I'm not just talking about horizontal scalability, which read replicas do, right? I'm also talking about vertical scalability. And when I talk about vertical scalability, it's like just adding more hardware, more memory, more processing, more network bandwidth and throughput to your database. So what you can do to have this infinite power, right? That whenever you want to just have more power, you will just scale it out, and you will have no downtime, right? Aurora serverless comes here, right? It just creates a database endpoint for you without specifying the DB instance class. So that's really important. Sometimes when your database workloads are unpredictable and they are uncertain, and is it actually infinite? So yeah, you can say that, but of course, just to I mean, a lot of Spider-Man references here, but with great power comes great responsibility. And like if you scale like just like anything, you will of course get cost, right? You want to throttle your database at certain point. That's where capacity units come into picture. So whenever you check any serverless services within AWS, there's a concept of capacity units that you can provision, right? These capacity units help you to basically add one unit at a time, which is like a building block. So let's say, uh, in the case of Aurora serverless, you have something called as Aurora capacity units, and each ACU is like having a 2 gigabytes of memory. Okay, and it will have corresponding CPU and networking as well. Okay, and it can scale your storage from 10 gigabytes to 120 terabytes, of course. uh, that's the part of Aurora ecosystem in itself. But what serverless gives you is adding the capacity units one above the another, and trying to make sure that you auto scale based on the workload that is being handled, based on the CPU capacity. It intelligently just adds it. Okay, and yeah, you can specify the minimum number of capacity units as well. So you want a database to be warm, right? So you can do that, right? And I mean, let's say if you want like 2 GB or 4 GB of memory, you can still do that whenever your database is being queried, right? Without even any workloads. And it can scale up to a maximum capacity units, which is your ACU. uh, when I say capacity units, right, you can also have zero capacity units. And zero capacity units meaning, when I say Amazon Aurora had different storage and compute layers, uh, your compute layer can have zero capacities, but the storage will still be intact, right? So even though you do not have any compute power remaining within your cluster, you'll still have your storage intact. So let's say during the night period from 12 a.m. to 6 a.m., there is no one that is using your database. You can scale it down to zero capacity units automatically, and you will only charge you will only be charged for the storage, right, in this case, because there is no compute. So that's a really good offering from Amazon Aurora, and how serverless helps you to do that. You will all, I mean, this gives you an automatic multi-easy failover option as well, and it is an always encrypted database, and it's highly secure. You cannot deploy a serverless Amazon Aurora instance in a public subnet as well. So it's that secure. Talking about another Amazon Aurora offering, and as the name suggests, it's like a global Aurora database, and you will have like a master instance in one region, and you can have like read replicas in another region. So it's like you are doing cross region replication across regions, right? I mean, cross region replication, the name itself says you can just go across regions, but this is more towards Aurora, right? So when I say Aurora, Aurora gives you a scalability feature as well. So when we say you have a master instance and a read-only instance in Aurora, right, in a clustered environment of Aurora, you can have up to 15 read replicas, right? But in this case, you have a master instance and you have a read replica in a different region, right? Now, let's say you have a master instance in US, and you have like your India application reading from this particular database, which is synchronously replicated from US East 1A to AP South 1A. You can add read replicas to these region as well, right? So let's say you have a read replica a year, like it's just one instance. So now instead of 15 read replicas, you will have 16 read replica option to be done here. And of course that comes with auto scaling. Okay. So as I mentioned, it enables low latency global reads and fast recovery in case, let's say, something happens in US or something happens in India region. You can of course fail over to a different region, and your India users can work on this particular instance, the US users can work on this particular instance. And you of course issue write operations to your primary master instance. You cannot issue write into these read-only instances. But what Amazon Aurora Global offers you is you can also forward your writes from a read-only instance to a master instance. Okay. So as I mentioned, the secondary cluster is read-only, and it supports 16 replicas instead of 15. And you cannot auto scale the read replicas here in this case, but of course you can have read replicas in the master. The secondary clusters allows us to make an Aurora Global database available in a new primary AWS region, right? And of course, that will give you a lower RPO and RTO, which is recovery point objective and recovery time objective. That's not much important, but this is just good to know stuff. Okay, now let's go and see how Aurora is looking out here. So when you create a database here, you must have seen that there is an option of Amazon Aurora, and you can select the database that you want to create it for. So as I mentioned, it works only for MySQL and PostgreSQL. You can have a provision or a serverless capacity. Okay, so Aurora serverless is what you will select from here, or provision is something that you will select from here. So when you select provision, you can provision many of the other things, and if you select serverless, it will not do things. Let's say if I select provision, right, because it gives me more options to configure, and so that I can walk you through all of those. There's options for application, that if you want to have a single master or a multi-master, right? We just talked about multi-master configuration. You have uh, like engine versions to select, and you can just filter out if I want engine versions which support global database. So these are the engine versions that support global databases. These are the versions that support global as well as your normal database that we have like within a region. uh, you also want to support like parallel query, let's say. Then these are the versions that support parallel query feature. Basically, parallel queries help you query your data in a parallel fashion and basically scale out your reads, right? And yeah, when you select a template, you have an option to select production or a dev or test. Let's say we go forward with production. You can give an identifier to your cluster. You can give your admin password. You can create your credentials here. You can select the instance class, uh, which is, let's say, I mean, if I want to have memory optimized or a burstable one, or if I want to use previous generations of T2, then I can do that as well. And if I want to create an Aurora read replica reader node, then I can use that. Or let's say if I want to use a master node to read as well, I don't want to create a read replica, I will not select that option. Note that this is chargeable, this is not chargeable. This is only charged for like one master instance. You can deploy your cluster within the VPC, and you can now select like a subnet group within which you want to deploy it in. And now, as I mentioned, it is very important that you select the same subnet group. To have like a multi-AZ deployment, uh, which will really help you to scale out when you don't have cross-region replication. Uh, you can also have public access, yes or no. You can select a security group which allows the port of a database to be opened up to specific applications. You can also configure the database port here. We can have like initial database is name. You have a different parameter group, right? So there is a new concept here which is called as a cluster parameter group, right? So just like how you configure your parameter groups for a database, you can also have like a parameter groups for a cluster as well, which will help you configure things on a cluster level, right? And if I can also select like what would be my failover priority, and there are different tiers for a failover priority. You can just look. You can just check about this, and we'll have backup retention period as well of however many days we want, till 35 days. And we can enable encryption. You can either select a RDS key from KMS, or I can create a new key and encrypt that database using that key, right? I can have a point in time recovery using backtrack, so you can just enable that. You can have like enhanced monitoring. Just it's in the same way that we have in normal RDS, and automatic manual version upgrade. So backup and snapshots, all of these concepts, backup, snapshot, security, and everything, it remains the same, just like how we have in RDS, we'll have in Aurora as well. Yeah, so that's it, I think, on the Aurora side. Moving to the next topic, which is ElasticCache. So ElasticCache is a distributed Redis and Memcache offering on AWS. And why do you want ElasticCache is like the first question you'll have. So caching, right? Caching is a concept that we often use for applications where I want less latency and I do not want my database to be overwhelmed, right? I can just directly use the data that is already cached. ElasticCache basically uses it uses memory, right? It doesn't use disk. So as I mentioned, memory is faster and disk is slower. And ElasticCache provides you high performance. It provides you high scalability and cost-effective caching solution, and also removes all the complexity that is associated with deploying and managing a distributed cache environment. Uh, you also have like an option where you have your in-memory database which is managed by AWS. Uh, of course, AWS takes care of your operations, so that's the benefit of moving to cloud. And an ElasticCache is like a cluster of high performance memory chunks, and the cluster has nodes, and each node is having a fixed size chunk of secure network cached RAM, right? So when I say RAM is like a memory, and you have like each node that's running having an instance of the engine that you selected, either Redis or memcached. I would strongly recommend you to use Redis because of some of the advantages that we will see in the later slides. Every cache node has its own DNS name and port to which you can connect, right? And you will also have like multiple types of cache nodes, which will give you varying amounts of memory. So let's say you have a cluster, ElasticCache cluster, a Redis cluster of 100 GB of memory, having 4 nodes. Basically, it's like a 25 gigs of memory spread across 4 nodes. So 25 into 4, which gives you 100 gigs within that cluster. It also helps you reduce the load on the database by caching the frequently accessed data. Of course, this is really important, and we'll talk about this later in the next slides. It also helps you manage the user sessions in memory. So you need not go to your disk and just check if the user has already logged in or not, right? Within your application, if you go to different pages, right? It really helps you for authorization. Uh, Note that ElasticCache doesn't have any IAM support. It has its own authentication mechanism. Redis has support for SSL, and Memcache has supports for SASL. These are different algorithms for in-flight support. Now, ElasticCache gives you an option of Redis or Memcache. What to use and which one to use. Redis shard is like a grouping of 1 to 6 nodes, right? And if a Redis cluster is deployed such that it has only one node. Even though it has one node, we call it as a cluster, and it has like one shard in this case. uh, ElasticCache can have like 500 shards, and when the cluster mode is enabled. So basically, if you have like more than one instance, you can have at max these many shards. It's ElasticCache also supports read replica and multi-AZ failover support, right? So multi-AZ is mainly used for failovers, right? For high availability. Memcache supports multi-threading, which ElasticCache may not support, which has a different way of implementing that. Uh, and In Memcache, data is partitioned across shards. So your data will be distributed across the nodes. It won't be like your one node will have all the data. There is no data replication or multi-AZ support in Memcache. That's why I strongly suggest to use Redis. You can see here in the table there are quite some differences within Memcache and Redis offerings. The major one, apart from the ones we discussed, is the data types. Redis supports some complex data types which are quite useful. So, what are the caching strategies which you should use as a good practice, and which is really important for a solution architect? RDS, so a database, right? A database, whenever you query a database, it has to do something, right? It ultimately goes to your disk, and it tries to read the data from the disk. It takes a lot of time for disk to work, and it's quite faster if you use something that is not movable, something like in memory database, which is Redis in this case. So here comes the ElasticCache offering, right? And there are some caching strategies that you can use for your application so that it can give you less latency while reading the data, right? Um, so the first option is lazy loading. So let's say your application tries to, you can follow my pointer. So let's say your application tries to access the cache. The cache is a mess. Okay, it doesn't find the data within the cache. The application is now supposed to get the data from the RDS, and now the data will be shown to the user, and our application is now supposed to write the data into the elastic cache again, right? So the next time the same data is read again, it would be a cache hit, right? And it need not go to the RDS. So your reads will be quite fast. Now, there are certain caveats here. The first caveat is a cache miss penalty. The cache miss penalty is like you are now going to go back to your database, your data will return, and you need to write back to the cache. So this is like a hefty penalty that you will have to bear the cost for. uh, Another one is, what if your application wrote some data to RDS, right? Your cache will be a hit every time it goes to ElasticCache. So ElasticCache will have like version 1 of the data, but RDS already has a version 2 of the data. So this is like a stale data problem, right? So what you need to do is you need to basically invalidate the data or cache within this. So the next time your application tries to hit it, it will miss and it will go back to the database and get the latest data, which is my version 2 data, and now it will write that to the cache. Okay, so how can we do that, right? I mean, this is a really complex problem, and it is also said in computer science, there are only two hard things, which is cache invalidation and of course naming things, right? It takes a lot of time to name things. Yes, it is legit when you are working with hundreds of files and hundreds of different resources, just to make sure that it makes sense. um, so the next offering is a write-through cache, which updates the cache every time, right? Whenever there is update in the data. So the application now is responsible to update the database as well as the cache. So rather than a cache miss penalty, now you will have a write penalty. The write penalty is lesser than a cache miss penalty because here you have like multiple transitions. But in the case of a cache miss, a write penalty, in write penalty you will only have like one transition that goes to a RDS and another transition that goes to your ElasticCache. Now, what about the initial data? I mean, your cache will not be always be having that data, right? To update or to write the data for. So how do we populate initial data? That's the first question. And what about the amount of data that we store in my cache, right? The cache churn that we call it, right? So these two problems that we have, the first problem, that is write penalty, right? So it's a general tendency and intuition that whenever a user accesses an application, the reads need to be faster and the writes can take some time. I'm not saying a lot of time, but it may take some time, and a user is expected and user knows that it will take some time. Okay, so I mean, your writes are a write penalty is still okay, but now your reads are quite fast because you always get latest data and you will not be missing a cache, right? Even though you do like even though you miss a cache, what you can do now is implement a hybrid approach. But before implementing the hybrid approach, right, let's talk about what about the cache churn. That is the second problem, where I cannot store everything within my database within my ElasticCache, right? So what to do about it? I only want to store the data that is already being used by the users currently, right? And I also want to make sure I'm not having hefty costs, because this ElasticCache is a cost. I mean, the resources are quite costly, so I don't want to have like an over provisioned ElasticCache cluster. So what I can do is I can implement TTL. This is like a time to live for every cache item, and here you can have advantages of each strategy now, where if there's a cache miss for the first time, it will go and take the data from RDS, right? And it will write to the cache. Okay. The next time an application updates the data, so whenever there are inserts, right, an insert will happen to the database, right, and it will also have inserted into the cache. Okay, so that's my cache miss. If let's say I'm also looking up the data before writing it. The second part is I'll also update the cache whenever there are any updates to my database, right? So that's something I can do using write through. So I implemented lazy loading for my initial data, implemented write through for my updated data, and to make sure that I only have latest data, I also implemented time to live. So I can auto discard the data which is not required within my cache. So this is the caching strategy that we can implement, right? Moving on, moving on to DynamoDB. So DynamoDB is like your NoSQL key value serverless database, and it's like storing your data in a key value fashion, and it doesn't follow like it doesn't have like a relation between. I mean, it doesn't have like a fixed number of columns like we have in relational database. You can have like flexible amount of columns and things like that, and we'll go through how DynamoDB distributes your data, right? So what DynamoDB is, it's like a fully managed, fast, NoSQL key value database storage, right? So you need not provision any hardware. It's a serverless service, right? It doesn't have any running servers. You only are charged for the amount of data and the amount of capacity units that you consume. So when I talk about serverless, capacity units come into picture, which we'll talk about it later. Okay. You have replication, software patching, cluster scaling, and like everything is already inbuilt into DynamoDB. You have point in time recovery. You have backups up to 35 days. So even here you can have point in time recovery. It also supports transactions. So you have that atomicity where if any of your writes or any of your operations fail in a certain table, the whole transaction fails and the other transactions are rolled back. The other operations are rolled back within the transaction. Uh, it also allows you to delete the expired items by using TTL, just like how we have in ElasticCache. Similar concept we have in DynamoDB for a TTL here, which helps you reduce the storage. Right now, how DynamoDB table is like how is it designed? Right, so a DynamoDB table has a partition key, right? Using which your data will be partitioned, right? And there is a sort key using which your data will be sorted within those partitions, right? Together, the partition key and sort key constitute a primary key. Note that the sort key is optional. If I don't want to sort, if my order of the data does not matter within the partition, I may not specify a sort key. In that case, my primary key is only the partition key here. Okay, and I have, apart from these, any other column that I have, these are certain attributes, right? And each row within my DynamoDB table is called an item. So like we have like one item each. I mean here in this case, so let's say if I have a partition key and sort key, which is my primary key, I always need to have a common. I always need to have a unique combination. So product ID 1, book ID is my unique combination. Product ID 2 and album ID is my unique combination. But within the same partition, I have another sort key, which is album ID and track ID here, right? So this is actually giving me like a different combination, which will be allowed by DynamoDB. If in case you are trying to write the same item with the same primary key, the item will be overridden. Okay, that's what you need to take care of. DynamoDB, when you talk about DynamoDB, capacity and consistency are very interesting and related concepts. So you need not learn more about this one, but let me just go through what are these. So when I talk about serverless, capacity units come into picture, and you have read capacity units and write capacity units in DynamoDB, right? And you have like you can plan your capacity if you have like predictable workloads, right? And you can auto scale the capacity as required. That's an option. And yeah, that's good for a provision capacity, which is a default mode, right? How to plan a capacity, that depends on the amount of data you are trying to write or retrieve, right? If you're trying to write a lot of data, WCUs needs to be increased. If you're trying to read a lot of data, RCUs need to be increased. There is a way you can calculate it on how each capacity unit can hold the data. So that is something you can provision accordingly using the formula. We did not talk about the formula as of now. Let's move on to an on-demand capacity where you need not provision the RCUs and WCUs, and you only pay for the request that you made, either for writes or the reads. DynamoDB will automatically provision the appropriate amount of RCUs and WCUs, and it will charge you per capacity units. Yes, It will be expensive in this case, but sometimes it's required for your unpredictable workloads. And yes, this is really good for scaling your throughput, right? Note DynamoDB gives you a millisecond latency in retrieving your data. Uh, Talking about consistency now, right? Data consistency is really important sometimes, and you may also find that consistency is not that important for your application, but or you may also have workloads which require strong consistency of data. So what do you mean by eventual consistencies, right? So let's say I wrote some data, right? As I mentioned, DynamoDB has millisecond latency. Let's say writing a data took me around 10 to 20, let's say 10 milliseconds to write, right? Okay. And uh, I'm trying to read the same data, and that read operation finished within 5 milliseconds. So if this read and writes come parallelly to DynamoDB, you will still see old data because this is milliseconds, right? A human doesn't understand that millisecond difference, 5 millisecond difference. You will still see old data uh, because this is eventual consistency. Now, let's say if you try to do another read operation after 5 milliseconds or so, at least 5 milliseconds, that's what I would say, then you will, of course, get the right data that you have. What strongly consistent reads are? Of course, these are most up-to-date data. You will get more latency. So let's say your writes came in after 5 milliseconds. In this case, your writes will take around 10 to 12 milliseconds because your reads will take 10 to 12 milliseconds because your write took around 10 milliseconds, right? So it uses more RCUs or read capacity units to hold that data for that time. uh, and yeah, so eventual consistency reads take less read capacity units, but strong consistent reads take more read capacity units because it tries to hold more units just to give you more data with some increase in latency, but still it is in milliseconds, right? But what if I want my data in faster manner, right? I want my data in a microsecond, right? So Dax, a DynamoDB accelerator, gives you a microsecond latency, even for at least for the eventually consistent reads, which is my fastest read that I can have in DynamoDB. uh, let's say your applications are quite demanding and they want to read a lot of data from DynamoDB. Dax is something that you need to use. Dax also helps you to avoid over provisioning your RCUs, right? So if you are reading a lot of data, Dax will be used directly rather than using your DynamoDB itself. So Dax is like a layer above your DynamoDB, as you can see here, and it is like a cache, and you can sort of use this cache with your application just like how we saw in the previous slides for ElasticCache. Similarly, you can use it for DynamoDB. The DAX works in a similar fashion, but especially for DynamoDB. uh, uh, like you will also get to understand, okay, why can't I use ElasticCache here? Yes, you can use ElasticCache as well, but the difference is Dax cluster is managed by DynamoDB and not by your application. Okay. In case of ElasticCache, your ElasticCache was managed by your application, where your application was writing the data. Your DynamoDB is supposed to write the data to Dax cluster, and whenever you query. So by this, you will also understand that there is a strong layer of abstraction here, and your existing DynamoDB APIs are already compatible with Dax cluster. Okay, so if you already have an application that is interacting with DynamoDB, you can also have it interact with Dax cluster directly if you just provision a Dax cluster, right? It requires almost no to minimal changes within an application to use Dax cluster, right? Your read heavy workloads will really benefit from this one. And you will not have to over provision your RCUs because your DynamoDB will not be used. Instead, your cache will be used directly. Now, when we talk about cache, time to live comes into picture, and of course, a 5 minute TTL is sometimes required. Right? That's a by default value, and you can of course increase or decrease it. DynamoDB Dax also supports encryption at rest and in transit using SSL. The question is when to use ElasticCache and when to use Dax as a solution architect. So Dax only caches an item of the DynamoDB, right? It doesn't cache any aggregated data and things like that within your cache from the DynamoDB. So to do that, you can use ElasticCache to cache some of your ad hoc data that is being retrieved from the database. But for item level caching, you can use Dax. Okay. Moving to DynamoDB streams and global tables. DynamoDB streams, I mean, it's like an ordered flow of information. So any operation that you do on your DynamoDB, right? All of these operations are, I mean, you can say streams are like transaction logs, and any operation that you do, that operation is written into a stream, right? A DynamoDB stream, and it stays there for 24 hours, and after 24 hours you will see all of these stream records eventually will fade away across the next 24 hours as and when all of them expire with a TTL of 24 hours. So DynamoDB streams is an ordered flow. You cannot have like an ordered flow in transaction logs. DynamoDB streams capture information about every modification, as I mentioned, and it writes streams in near real time. Okay, so it's really important to know all of this about, at least about the DynamoDB streams. Now, DynamoDB also supports something called as global tables, where you can have your DynamoDB table spread across different regions, right? You can have a DynamoDB table also being used in a different region. So how to make sure that all of these DynamoDB tables are consistent across different regions, right? Because this is a global table. If a DynamoDB table is being used in US, I also want to use it in India. I can do that by enabling DynamoDB global tables. It requires DynamoDB streams to be enabled by default. That's when how it leverages streams, right? It uses your transaction logs, your streams, and changes your data, and it tries to write this into the global tables, basically your other DynamoDB tables which are spread across the globe using the streams. So it does this near real time, right? As the streams are written near real time. Moving to indexes, DynamoDB indexes. This is also very important. Just like in a normal database, right? If you're reading, if you're trying to query your data from certain columns, and these columns are having like a certain level of cardinality, you do want to make sure that you are able to query this data in a faster way. So what you do in a normal database, you define an index. So a local secondary index is useful to define that additional level of indexing, right? So you already have partition key and sort key, which will give you a good level of performance. So what if you want to also filter upon another column which has high cardinality? In that case, you can use a local secondary index. You can say that it works as an alternate sort key, right? And it of course projects your existing keys as well. So whenever you're trying to query your data with the LSI, which is a local secondary index, it tries to directly point to the local secondary index, and it will use a partition key, your sort key, and your LSI, which is an alternate sort key, together as one, and try to get your data faster. You can define more than one LSI and have up to 5 LSIs per table. Talking about a global secondary index, right? Here in the local secondary index, one of the thing is, as mentioned in the second point here, it projects your existing key, which is a partition and sort key as well, right? What if I want to have like a different key in itself? So global secondary index help you to do that, and global secondary indexes are sort of like a views over your DynamoDB table. So every GSI must have a different partition key and can also have an optional sort key, just like a normal DynamoDB table, right? The index key that we have here for the GSI need not have any of the key attributes that you already have within an existing table. Note that duplicates are allowed here because this is like a view and not like a DynamoDB table, right? DynamoDB table does not allow duplicates using the primary key. Global secondary indexes allow you to have like a duplicate data for the key that you define, for the partition key that you define, right? Uh, of course, for the respective DynamoDB tables, you cannot have duplicate data, but for the GSI, you can have duplicates within the new partition key and the sort key. As I mentioned, it acts like a view over a DynamoDB table, and you can create up to 20 GSIs over the table in DynamoDB, which is like a limit. Now let's go to the DynamoDB console. Okay. Yeah, let's go to the console here. DynamoDB. Okay. Yeah. So let's try to create a table here. You can give a table. Let's say I give a test table. I give the name of test table. Okay. Uh, like you can define a partition key. Let's say I'll give a partition key of name, ID, and a sort key of name, right? If I specify a sort key, that means both partition key and sort key both together acts as my primary key. Now, in this case, settings. Let's say I want to customize my settings, so I can walk you through all of the options. So there are two different table classes that we have these days, which is DynamoDB standard and DynamoDB standard infrequent access. Uh, this is like your storage class that we have in S3. You have like a different storage, pricing for both, right? And let's say we go forward with DynamoDB standard or infrequent access. You can choose either of them. Based on that, you will have an option now to calculate the capacity, right? Now let's say I want to have an I want to calculate the capacity where I'm going to read a item of maximum size of 30 KB from my table. I'm going to have 5 reads per second, and per second my application can have like 3 writes, right? So automatically DynamoDB will give me, I need to provision at least 20 capacity units and 90 write capacity units, right? An estimated cost of 45 to $46 per month, right? I can have like a capacity either provision. So in the case of provision, I can have like my capacity units mentioned from 1 to 10 and 1 to 10 here. Uh, so, so this is like a maximum cost, and I want a standard consistency and for writes and eventually consistency for reads. Okay, and let's say I have like an on-demand option, and in case of on-demand, I do not need to provision any of this. Automatically, DynamoDB table will take care of provisioning the capacity for reads and writes. Let's say if I go to provision, the auto scaling option is enabled for me. I can auto scale from 1 to 10 for reads, 1 to 10 for writes, and it will only auto scale when my utilization is around 70%, right? It will add one capacity unit each for every time this target is crossed. I can also create local indexes and global indexes here. Uh, Note will also have an estimated cost, and you can also have like your encryption configured here, and you can now create your table, right? So let me just go back and cancel this and just create a table for you, which is like a test table. And my partition key, as I mentioned, it's an ID and a name. I want default settings. I'll just create the table here. Okay, for the simplicity of the demo, it will not take much time. It's already active here, the test table. I'll view the items. I'll see there are no items written, right? When I go and see the table details, right, you can see here that I have a ID as a partition key and the name as a sort key. I have not defined any other columns within my database, within my table, right? DynamoDB table does not have the concept of databases. That's something that is really good to know. And you can also define, you can also skip to define your columns. So based on the item being returned into your DynamoDB table, automatically your columns can be added. Okay, and you can define your indexes. So as you can see here, right, you cannot define a local secondary index after you create a table. You can only define global secondary indexes, which is basically you can define views over your tables only after you create the table. Because local secondary indexes tend to compute things, you will only have to provision it at the time of creating the table. What you can do in this case is you can copy the data from one table to another table which has an LSI created for you in case you want to add an LSI later. You can also have like global tables, you can have backups, you can have like exports and streams are also configured, right? So that's what you can do. The capacity is already planned here. I can also have a TTL enabled for my table. I have an encryption option, which is managed by DynamoDB in this case. Let's go and try to view the items, right? There are no items that are written. Let's say I try to create an item and I have an ID of 1 and the name of, let's say I give my name. I add a new attribute. So these are the different attributes that DynamoDB can have, right? A string, number, boolean, binary, null, anything, right? Let's say I want to have like a list of values, and within the list of values, I want to insert another list, right? So this is what I mean. You can understand, right? Here, I can have like a hierarchy of data. That's why it is called NoSQL data, right? So let's say I give a new value of say scores, okay, and this particular new attribute I want to add as a list. Okay, I want to add a list within this one only, and these are the elements within my list. I want to add a string value, I want to add a number. Okay, a string. Okay, so let's say I have like a and b here. I have like string added here, which is a c, and d here. Okay, now when I create this item, right, you can see here, right, it created one record which is uh, like the partition key of 1, sort key of name, and there are scores here. So here if you see, right, it gives you data in this fashion, right? And what this means is L means a list, S means a string. So this is like an additional metadata that you can get for your data within the list. Ensure that DynamoDB, even though it's NoSQL, there are multiple types of NoSQL databases, and DynamoDB is a key value NoSQL database. Though it can store an object and hierarchical object within the column, if you want to update a single attribute within like layer 2 or layer 3 of your data, then in that case it will have to write the whole item rather than writing just the exact value uh, as layer 2 or layer 3, right? So you will only be able to update the data which is there within the value of your key, your DynamoDB key, right? So whenever you have updates, let's say you want to update this particular value, it I mean, of course there are some custom utilities that you can use to do it, but ultimately it tries to just write the same data again with the updated value in the hierarchy. So going back, I mean, just going through this particular console, right, we can also define a Dax cluster. So when you define a Dax cluster, you can see here, you can give a cluster name, the type of the Dax cluster you want to create, and the number of nodes that you want to have. Let's say I give a name of ABC. I'll just demonstrate how to create. I'll not provision one. Uh, let's say you want to create a subnet groups and things like that. You create availability, select the availability zones and all. You can have access controls. Just create a Dax cluster, right? Now, from your tables, if you go to exports and streams, right, you can also define what if I have defined a stream for my DynamoDB, you can also do that. Within DynamoDB, you can define that, and you can also export it to S3. I mean, export your objects from DynamoDB to S3 here, and you can also enable DynamoDB streams from here. as I mentioned. Right, you can have backups, you have parameter groups, likewise we have in RDS, you have subnet groups, you have like certain events that happen within a DynamoDB table, things like that. So without going any more time, I hope that DynamoDB was clear, at least for the solution architect certification. I think this is good. Now moving forward to the three important services, you need not know quite in detail, but you should know what it does, and we'll also do some demos on these, which are quite interesting, right? So coming to Redshift, it's a data warehousing solution on AWS, which uses PostgreSQL, but PostgreSQL being a OLTP system, this is totally rewritten, and it is used for rather an OLAP solution, right? Like for an warehouse and for analytics workload. It is a columnar storage as a warehouse is supposed to be, and it supports massively parallel query execution as well. You have like a leader node, and then you can have uh, uh, like compute nodes, which are like 1 to 128 node cluster. You can have up to 128 TB of storage per node. So this is like a legit warehouse which for big data analytics. You can have like data that can be loaded from S3, from DynamoDB, DMS, anywhere, right? This is like you are actually connecting to Redshift by leveraging connections that we do using PostgreSQL. But the underlying infrastructure, the underlying architecture is totally different for Redshift, which we'll see in the later slides, which is really interesting to know. Uh, you have like a concept called as copy commands in PostgreSQL. The same applies to Redshift, and we have like optimizations that are done on Redshift, which helps you to do reads and writes to and from S3 in a parallel fashion, like we do in a data warehouse for like TBs and TBs of data. You have enhanced VPC routing, which helps you ensure that the data is flowing within your VPC and not outside your VPC to have like those compliances. And note that Redshift has no multi-AZ. Uh, so any failover that you want that happens, that you need to do from an automated manual snapshot, right? For disaster recovery, you can configure the Redshift cluster to be copied over by basically copying the snapshot itself to a different region. So whenever a DR activity happens, it can directly fail over to a different region and upgrade that cluster to have like the master node and use the endpoint of that cluster within your downstream applications and upstream applications. Moving to the next slide, which is Glue. What is Glue? Glue is a serverless ETL service. When I say serverless ETL, it leverages the power of EMR, and it sort of scales out your Spark jobs, and it also has some concepts which are quite proprietary to Glue. And there is a concept of, let's say, dynamic frames. So all the data engineers out there, uh, just like we have data frames in Spark, right? We have dynamic frames in Glue, which has a flexible schema, and it also supports some very advanced transformations which Glue has in it. It is very easy to convert a data frame to a dynamic frame or vice versa. Glue also has a metadata repository, like we have the one in Hive for like we have a Hive meta store, right? Or we have Edge catalog. Similarly, in Glue we have metadata repository, and note that you need not store this metadata anywhere on server. I mean, this is totally a serverless service, right? You are only charged for the amount of computation that you consume and the data that you consume, right? So basically DynamoDB, the Glue metadata repository, which is also called as the Glue data catalog. It consists of the table metadata, right? So that it can work on semi-structured and unstructured data on S3, let's say. Okay, you can also define data catalogs on relational databases as well, or in DynamoDB. Like we see in the below diagram, the glue data catalog can be cataloged from an RDS or from S3 or DynamoDB or any JDBC compliant sources, right? There is something called as glue crawler, which sort of crawls the data from all of these databases, okay, and tries to write the data catalog. And you will now have so data catalog does not store data, right? It stores the metadata of the tables. So whenever you try to query a data catalog, the data catalog will go out and actually read the data from the storage services. Okay, so we have certain serverless services to query the data, which is also called as Amazon Athena, which we'll talk about. And there is something called as Amazon Redshift Spectrum, which utilizes the power of Amazon Redshift, and it has something which is very much special to Redshift Spectrum that we'll talk about in the later slides. So using crawlers, you can just crawl your metadata, and you can schedule this crawler to sort of crawl this data every few hours or every few days, so that your data stays in sync, right? Let's say if there is a new file that is incoming with an additional column, your glue crawler can take that additional file into consideration and add that another column into the meta store. So the next time when you try to access that column from your data catalog, it knows that new column to look for, right? So let's move on to a Redshift and a Glue demo. Okay, so I already have like a sample data, right, which is loaded into an S3 location, right? So this is the S3 location that I have, and this is the sample data. This is the CSV data having like 4 to 5 records. A very very I mean just 2 minute. It took me just 2 minutes to create this data. It's a very small kind of a CSV file, and what we'll do is we will try to populate my data catalog, right? We already have like a crawler that is defined over this. So let's go and see what the crawler is. So this is the glue service, and these are the crawlers. So when you try to go and see the crawler, right, you have to specify the name of the crawler. When you click on next, you need to select the data stores, and you say, okay, I want to crawl all the folders within the S3 path that I will provide. Okay, what is a data store? Is it an S3, a DynamoDB, a DocumentDB, a MongoDB, or a JDBC compliant sources, which is also, of course, all the relational databases are JDBC compliant. So you can also have all of them here. So let's say I want to do populate it from S3, so I can have a structure defined over my semi-structured, unstructured data on S3. I can crawl the data in a specified path. So I've said, okay, crawl it in this particular path, which you can see here. It is there in this particular bucket. Now, let's say I also want to exclude some pattern. I can also do that as well. I don't want to do that. I just have one file in my folder, and I want to create a catalog out of it. I click on next, and I'll basically add if I want to add another data store, I can do that. If I don't want to do it, I can click on no. Click on next. You need to select an IAM role that allows you to read data from S3, and of course a glue service role. All of these permissions you can just check out later. And I want to run it every hour, every daily, or I mean however I want. I can also define a cron expression. Let's say I want to run it on demand. Now you can also group that data. You can just read it out what it does here. It's quite handy to have all of these configuration parameters. I can give the name of the database. If I don't have a database, I can add a database first and then select it from here. Let's say I've already created a database called test sample. Okay, click on next, click on finish. Okay, now let's say I'll just click on this and I'll click on run crawler, right? So when I run this crawler, what it'll do is it will try and go to this particular CSV file and try to extract the schema out of it. Okay, so when it tries to extract the schema, you will see that it populates. It will take around a few seconds until it completes, and once this completes, right, you will see that there are certain tables that I've already created, and once that crawler completes, right, you will have this particular table created. When you click on this, the crawler created this table, and you have like these columns, and there are around 5 to 7 records in my table, and uh, I am skipping like the first line of the CSV file that I have on S3. Any other properties and survey parameters are defined here. So what it does is it just created a schema for me over the data in my S3. Now let's do one thing. Let's try to sort of create another table, right? Which I've already created it for you. So all you need to do is like add table manually, and you need to define the schema here. So I've defined the schema. I've also defined that, okay, my CSV file has the first line as header, and this is the separator char, right? It cannot infer the schema, so you'll have to specify one, because the ultimate goal of your meta store is to actually have a schema, right? So I've defined the schema manually. What I'll do is I'm just going to copy this table from here to here, okay? And when I try to query these tables, I'll be able to get the data, right? So we'll talk about querying the tables later, but before we go to that, let's see what are glue jobs. So I've already defined a glue job, which is a very basic job here. Maybe if you need, I can just delete it, and yeah, when I click on add job, I can give a name of the job test. I can click on I'm role. I can select Spark 3, let's say, and yeah, I'll just keep other things as it is. What I'm going to do is I want to have a data source from where I need to read the data. Okay, I'll select that. I click on next. So I've selected the data catalog which was populated by my crawler. If I want to change the schema, I'll click on this. I'll just click on next by selecting this. Okay, use tables in your catalog. I'll just click on glue job output. Okay, so this is the mapping that you can define. You can just remap this, all of this, and click on save job and edit script. So what it does is it creates sort of a DAG for you, and you can just see what it does here, right? And you can see that it reads, it applies a mapping, it selects the fields, and finally writes it to uh, basically a catalog. So glue also generates the code for you, a basic boilerplate code based on the configurations you did. So all I want to do is read from my catalog sample and write it into my sample glue job output. So this is the table that I created manually in my data catalog that we talked about previously. And when I run this job, right? Let's say if I run this job, what we'll do is it will go and write the data from this sample data CSV, right, to this particular table that we created here in the data catalog, which is a glue job sample output, right? Uh, and when I say it writes the data, as I mentioned, data catalog doesn't store data in itself, right? So what it does is it writes into S3. Okay, so whenever you create a table, right, you give a S3 path. So it tries to write the same data with this name into the CSV file and in this particular bucket. Okay. So when the job completes, it will sort of now write the data. Okay. Now as you can see, the crawler also, I think the crawler completed, and it has already crawled my data, and I have this particular table here, which is already crawled by it. Now, when you go and check the job, which we have here, yeah, it says succeeded. And when you when you basically just go and visit this table, right? This table will give you how many records it will have. It won't give you because this is like a custom table, but if you see here, this is like a crawler created table, so crawler knows how many records were there, so it sort of wrote those many records here. But actually you cannot rely on this one. It may be different within your file, right? So you have created like two tables here, and both of these tables are populated. Now what I want to do is I want to query these tables in S3, right? I want this data in S3 to be queried upon. You can see here, glue job wrote this particular file again with a different name, and this file is now being referenced by my crawler here, by my data catalog here, which is my glue job output table. Now, what I want to do is I want to query this data. How will I do that, right? So glue was able to read the data and write the data back into another table, right? Into another catalog. How can I make sure I want to also query it with like a proper UI and SQL, right? That's when Athena comes in. So Athena is like an interactive serverless query service, right? It helps you to analyze your unstructured, semi-structured data. Of course, you can also do structured data querying using Athena as well, using standard SQL. Uh, uh, on the backend, Athena uses Presto, which is a distributed SQL query engine which leverages the power of the data in a object storage, and sort of scales it out to get your actual data using a catalog, right? So if Presto was using Edge catalog, or if Hive Metastore, Athena will use Glue data catalogs, right? So that's what you can infer from whatever we discussed till now. Athena also uses ANSI SQL, and you only pay for the data scan. So Amazon Athena is a serverless service, right? And it does you need not have to provision a capacity unit here. So automatically, based on the query that you do, right, and the amount of data that the query scans in S3 using the catalog, it will charge you based on that, right, and the amount of time it takes. uh, Athena basically works better on columnar data formats like Parquet and ORC. So make sure if you are going to basically do things on Parquet or ORC, and want to use Athena, that's the best way to do it. Uh, uh, I mean, only if you want to, let's say, do some very basic level analysis, right? That's when Athena will be useful for you, because since Athena doesn't have server, it tries to scale out and basically pays for the data scan. You have to make sure when you can use Athena, right? And when you have to use something else. And what can Athena query? Athena can query virtually all the JDBC compliant databases, and also DynamoDB, HBase, Redis, and likewise other databases as well. But Athena doesn't have the power to do things in a like for a lot of data in a scalable distributed way, like how Redshift may do it in a server, in a completely server way, right? Uh, uh, how do I make sure that I leverage Redshift's compute and also able to take the advantages of data cataloging and still have my data on S3? So Spectrum comes into picture here. So how your Redshift works is whenever you do a query, right, it sort of leverages its infrastructure and tries to sort of distribute your query across multiple nodes, and aggregate that data and give you the output. Redshift Spectrum adds another layer where all your data that is there within the nodes, they will now call Redshift Spectrum nodes, which will give you a fleet of instances, which Spectrum does it automatically for you, and it tries to aggregate the data in parallel, and it's quite fast, and it's quite faster than Athena as well. And it is useful for complex operations where you do not want data to be loaded into Redshift. You want data in S3 only, and leverage the data cataloging in Glue, but still have that query performance. So Redshift Spectrum comes in handy in this case. So as you see, it uses data catalog and the S3 the S3 storage where you have your actual data, and based on the distribution of the spectrum nodes, automatically your data will be aggregated. So let's go and have a quick demo on Redshift and Athena. So as I mentioned, I want to query this data, right? I want to query these the tables that are there in my catalog. I can go to Athena. There is an option called as glue data catalog and the tables and in the database that I have created in my data catalog. Once I see that, you will see you have two tables here. One table is your sample, and the table is your glue job output. Okay, so when I now view my data in sample, right, you will see that my file is loaded. Okay, but you may have a question. The file is loaded, but I have two sets of records. Okay, now just to make sure that I say it correctly, um, so the storage is separated out, right? It's in S3. So what I've given is I've given a path till this folder, till this prefix, and I have all of these files within my folder. So since both of these files have same set of data, and if you see glue catalog, it only has the location till here, it will now query the data from both the files and show you here, right? And same is true for this one as well. So virtually both of these tables, the catalog tables, are showing me the same data, right? Okay, it will show you the same data here. So Athena is useful here, and Athena just charged me for 0.41 KB and runtime of 0.4 seconds. Okay, now as I mentioned, Redshift Spectrum is the way to go for a complex query structure, right? Note Redshift, Athena does support federated queries, so it does have some advantages here. Let's go to Redshift Spectrum. Okay, so this is my cluster, and let's say I've already provisioned this cluster for you, and I've defined like a very basic cluster here, and you can now go to the cluster here and select the editor and go to a V2 editor, which will open this for you, and this will show you the databases. And once you select this database, you will have like set of schemas that are created for you. So let's say I select this dev one. Okay, and I've already selected the dev database here. What I want to do is I want to query using Spectrum. I want to query this data that I have in my catalog. I want to query my catalog, which is this data in my S3. I'll create a schema here. I'll give the name of the schema. I'll select external first, which is my external schema. So this is like an external schema for Redshift, right? So because this is like a data catalog. Now go to the database name. Let's say I want to select test sample, which is my glue data catalog database. I select an IAM role for this operation to get my catalog information as well as reading data from S3. So I'll select both of that, and yeah, I'll just need to give the name of let's say my schema that I'm creating here. So Redshift has this concept of schemas, right? That you can create within the databases. Okay, and even though we call this one as the database, so even though this is the database, right, within which we have our tables, we still call it as a schema within Redshift. Okay, so since it's a glue data catalog, it is giving me an option to select a glue database name, but we are adding a schema in my Redshift. That's what you can just need to make sure about the nomenclatures. I click on create schema. So create external schema is created here. So now when I just go here, I can see both of my tables, right? I'll just select this table and I'll run this query. What this will give me is the data from S3. Just like how Athena gave me, similar way, Redshift is giving me using Spectrum nodes. Okay, in a scalable way. Of course, this is a very simpler database, so we cannot actually compare the query performance in Athena in and Redshift. But I'm sure for some other complex operations, Spectrum will take the edge, right? So here you can see like the elapsed time is 1000 milliseconds, and here you can see like the time uh, at the time it took was zero point 0.4 seconds. So of course you can even see from this one that Spectrum is faster, so you use Spectrum for complex operations. Now Redshift has databases, it has table schemas within it, right? What if I want to create a schema and I want to copy the data from this particular file, right, into my Redshift cluster itself? So I don't want to rely on blue data catalogs here, right? So what I can do here, right, I'll create a table test, right, which will be similar to test sample table, which is nothing but our data catalog table, right? So this will create a table for me called test. Okay, let's do the query. Okay, I got 0 records because my data is not loaded. I'll use copy commands, which will copy my data in S3, which you can see here within the data store sample. We have a sample.csv. I want to load this data only, right? And using the IAM role, and since it's CSV and I want to ignore the headers, I'll use this. Okay, so it copied that data. Now let's try and query this. So what it did was it just copied one CSV file and created a managed table in Redshift rather than using XML table. So as you can see here, your data is now loaded from that one single CSV file, and we have all of those 5 unique records in this table, right, within the test one. So where is this table? It is there within my dev. If you go to public, there is a option to select tables, and here you have the test. Okay, notice it sort of didn't keep the ordering, right? And this is because the copy commands work that way, because you use the same copy command for loading thousands and millions of records, right? Do not want to do it serially, do want to do it parallelly. So so there would be records which will not be in the same order as they are in your files, right? Here we only have a single file, so that's fine. So here we also demonstrated how to load data into Redshift using copy commands and all. And yeah, I think that's about Redshift. Coming to the last part of the session, which is your Elasticsearch service in AWS. You will not find this service now because it is now renamed to OpenSearch, which uses an open source version of Elasticsearch, right? When you will use Elasticsearch, it is better than DynamoDB and at querying the data without defining any index. In DynamoDB, if you wanted to query the data, you had to define an index, right? And uh, I mean, you cannot actually implement a search or something like that if you want to search on multiple columns, right? It's, I mean, you can have only like 5 LSIs per DynamoDB table. So what to do in that case? I'll use an Elasticsearch and OpenSearch cluster, right? OpenSearch is better because you do not define any index and you can actually query on any column. It will give you the same output in the same speed and maybe better. It's quite fast. You can also have like partial matches of the column, like using a like operator and have like partially matched output from a particular column. It supports that. You can at a very base level, you can say that it defines index on every column. That's what you can say. And it of course requires you to register provision a cluster. So Elasticsearch OpenSearch, there is a cluster that you need to provision, and we also call it as domain in Elasticsearch. I mean, within the cluster, if there are any failures, open search service will automatically add that node. Basically, it's self-healing, and it's a fully open source search analytical engine for log analytics, real-time application monitoring, and clickstream analytics. It's quite useful in many of the search cases and pattern matching cases as well. It supports IAM access control, encryption at rest, and also encryption between the nodes as well. Note, you will have to encrypt the data that is being communicated between your application and Elasticsearch service. You have index level, document level, and field level security support. When you see documents in Elasticsearch, I mean in OpenSearch, a document is like it's like a record, right? And you have like cluster snapshots, just like in RDS. We have like backup and restore in OpenSearch as well. When I say OpenSearch domains, I mean the cluster itself. So Elasticsearch is often a part of a broader perspective, which we call as ElastiStack, which has two more services, which is Kibana and Logstash. Kibana equivalent in OpenSearch is called as OpenSearch dashboard. So you can also visualize the data in OpenSearch dashboards and have real-time analytics on that one. So I think that's about it. I think we are already like over time, and I hope this session was really helpful for understanding all of the databases and analytical services. And I think I would like to really thank for this opportunity to share my knowledge with you all, and I'm looking forward to meeting you guys again. Thank you, everyone, from the organization perspective, and thank you for joining. Yeah.
Thank you, Yash. I would say it was really a wonderful session, backed by a couple of good demos and good hands-on sessions. I hope everyone on the audience side would have learned in detail about database, which will help them to for sure get further certifications and other stuff. I would request everyone to please post their questions if they do have any in the chat, so we can have Yash to help you out. As well as I will remind everyone still, if you haven't registered with us, please do register it today. The link of the registration is given in the description of the video, so you can easily register with us with a simple Google form. So please do it today, so we can share all the materials and other stuff with you guys, right? And again, please feel free to ask any questions if you have. I think we do have one. Here we go. Can we replicate ElasticCache in different region? Which is from Dora. Yes, do you want to answer that?
Yeah, I think we can. I think we can do that. Probably not recommended, because you might have applications serving to a particular region, and you do not want that data to be replicated. I mean, replicating cache will have its own overhead, right? And the sole reason we have cache is to reduce the read latencies. So I think we should I think not have cross-region replication ElasticCache. I think we'll have to check probably, but yeah, sure.
And yeah, I think just want to add what Yash mentioned, right? We also need to be cautious about data sensitivity, because when you're moving the data from one region to another, right? And ElasticCache do stores certain of user-related information, which we need to be sure that if you're moving, let's say from US within the US states, it's fine. But if you let's say you're moving from US to UK or India, you need to look into the regulatory part of the data transit, right? So from that perspective, as Yash just mentioned, we need to avoid it as far as possible. But just in case, if you need to do it as a part of your business application, you need to be sure what kind of data you're storing in a cache. Please, guys, we'll have a few more minutes. If you have any other questions, please post around it. And yes, I would like to announce again for the people who are very active throughout the boot camp. At the end of the boot camp, in the last session, we will award the AWS certification vouchers and AWS credits. So please do participate in all the different sessions. Register with us, participate on the study group, the materials, and all of the stuff. We will award or recognize all those active contributors at the end of the boot camp. We'll wait for a few more minutes. Okay. I don't think if there are any question, I would like to announce once again, we have tomorrow on one more session, which will be around security services, will be conducted by Aishwarya Gupta. That will be around 2:30. The entire, the link and all the stuff has been promoted around the study group as well as on the LinkedIn. Please do join with us and let's explore, let's understand how exactly what we have learned today around the data stuff, how we can secure it better, your AWS accounts, your data security, and your application. So that's all. Okay, I think we have one more question. Sorry for that. Before we wrap up, what are the best practices for DynamoDB?
So there are many, I would say. So it depends on the workload. If you want to have like a global database in DynamoDB global table, then you, of course, there is no other option than using streams. Uh, the second thing is, let's say you want to have like your reads to be more faster rather than having a millisecond latency. If you want to have a microsecond latency, in that case, like having a Dax cluster is the way to go, rather than using ElasticCache or any other cache that you might have already in your architecture. So using Dax is the way to go. Third thing is always query your data using partition key and sort key, and define additional indexes for faster querying. And if you have like aggregations coming in from different tables, and if there is a need to define a global secondary index, then I would say please do define it, so that, I mean, just make sure that you are able to use uh, the capacity that you provision to your DynamoDB table up to the optimal mark, right? So you have read and write capacity units. Make sure you just use them appropriately.
Yeah. And also, I think outside from a certification perspective, if you check the reInvent announcement, I think there is infrequent access, which has been announced for DynamoDB. So do explore that if you want to ensure that the data which is stored in DynamoDB is not frequently used. So I think that's one of the good way you can cost optimize and get some more stuff, not from a best practice, but from a cost optimization also you can explore that thing. Any other questions before we wrap up today's session? Okay, I think we are good to go. Thank you guys for joining today's session. It was really wonderful, Yash. It was a really good session, and hope I see everyone for tomorrow's session in afternoon at 2:30 p.m., which is around AWS security. And yeah, please be active and please be safe. Thank you so much. Have a wonderful day ahead.
Thank
Thank
you.
you.
Bye.